Good morning, children. So, I'm starting the next chapter, superposition of waves, the second one, and the formation of stationary waves. So, if you want to know the formation of stationary waves, then before that, you need the concept of bounded medium. Alright, now bounded from the English term only you can make out means the medium which is surrounded by certain specific definite boundaries and which is the medium which is distinctly separated from any other medium, that is known as bounded medium. Alright, now bounded medium, again there are two types. One is known as rigid boundary, another is known as free boundary. When we say that rigid boundary means the boundary it is at a definite distance. Alright, then we say that bounded medium is having a rigid boundary. Alright, now when a progressive wave propagates through a bounded medium, then what happens? It will suffer reflection at the boundary. Alright. Now when it will suffer reflection at the boundary, then two cases will arise. Alright. Just first try to understand that suppose one wave is moving like this and it is suffering at a rigid boundary. Means this boundary is rigid. Alright, means what? Rigid boundary means what? Simple thing that boundary is visible. Boundary is certain definite distance. So you see the wave, this is the incident wave, it is moving, you see in this direction. So as it is moving in this direction, I should not give the direction sign here. This is the direction of propagation of wave. So it is moving along x-axis, positive x-axis. So you see what will be the equation for propagation? It will be sine omega t minus kx. I hope you can remember that when a progressive wave move along the positive x-axis, then the equation of the wave is given by y1 is a1 sine omega t minus kx. Is that clear? Now you see when it will suffer the reflection at the rigid boundary, then what will happen? It will not only change the direction, because you know that incident wave and reflected wave, they just move in opposite direction. It not only change its direction, but it will also suffer a phase change of pi. 180-degree phase change. Means what? You see, when the wave is propagating, then positive half cycle created, then negative half cycle created. Now, when the wave will suffer reflection at the rigid boundary, okay, here I am writing, it is rigid boundary, then what will happen? It will suffer 180-degree phase change. 180-degree phase change means what? Now, first the second half cycle will come, then the positive half cycle, negative half cycle will come, then the positive half cycle will come. Is that clear? So you see what will be the equation for the, this is the equation for the incident wave. Alright, this is the equation for incident wave. Then what will be the equation for reflected wave? Reflected wave, you see, as it is changing the direction, so this will become plus kx. You have to understand and remember these points. For incident wave, as it is moving along positive x-axis, so minus kx. Reflected wave, it is moving, this is the reflected wave. It is moving in the opposite direction, means along negative x-axis. So what will happen? It will become sine omega t plus kx. Is that clear? Again another point, you just look at it. For the incident wave, first positive half cycle, then negative half cycle. But for the reflected wave, first coming negative half cycle, then positive half cycle. What is the meaning? That it has suffered. It has, reflected wave has suffered 180-degree phase change. 180-degree phase change. Alright, so 180 degree phase change means what? It will be plus 180 degree, and now sine 180 degree plus theta is minus sine theta. So you see it will simply become minus A1 sine, okay, no need to write A1 because the amplitude and everything will remain the same. So it will become minus A sine omega t plus kx. Alright, so here lies the point. You have to understand that when through a bounded medium a progressive wave propagate, then it suffer reflection at rigid boundary. Then what will happen? There will be two change in the equation. What is the change? It will become plus kx, y plus kx, because the reflected wave reflected wave is moving in the opposite direction. Then another negative sign will come here. This negative sign for what? This is 180 degree due to the fact 180 degree phase change. Alright, why 180 degree phase change? I hope you have understood that first negative half cycle coming, then positive half cycle. Is that clear? So this is the physics behind the reflection of incident progressive wave through a rigid boundary. Next case is coming that the bounded medium is having free boundary. Free boundary means what? The boundary is at such a distance that the boundary is not visible to us, but there is a boundary. Alright. So in that case, what will happen? So you see, in that case, incident wave, suppose it is moving in this direction. So you can write what will be the equation for the incident progressive wave, y1 a sine omega t minus kx. Is that clear? Next, what will happen? Now we do not know where it has suffered the reflection. That's why you see I have not drawn any boundary. Just to get the same point, I have drawn this dotted line. Anyway, I am just rubbing it. So you see the reflected wave has suffered from that free boundary which is not visible to us, and then moving in the opposite direction. But as it suffers reflection in the free boundary, it will not suffer reflected wave do not suffer any phase change. This is the important point you have to remember. Means whenever reflection takes place in free boundary, then the wave will not suffer any phase change. So you see what will happen to the reflected wave? It will simply move in the opposite direction. So it will become plus, means it will become a sine omega t plus kx. But there will be no negative sign here. No negative sign here, unlike the rigid boundary. Why? Because it is not suffering. It is not suffering any phase change. So look at this one diagram I have drawn. When incident wave moving, first positive half cycle, then negative half cycle. When the reflected wave moving, then I have drawn the first positive half cycle, then negative half cycle. What does it mean? They are in same phase. Okay, so this is the basic concept of reflection of progressive wave through bounded medium. Once again, I am summarizing the details that bounded medium means what? The medium which is having certain definite boundaries and which are separated distinctly from any other medium. That is known as bounded medium. Then again, bounded medium, there are two types. One is rigid boundary. Rigid boundary means the boundary is situated at a definite distance. It is visible to us. And when a progressive wave propagates through a rigid boundary bounded medium, it will suffer reflection at the rigid boundary. Then due to reflection, it will undergo 180 degree phase change. I repeat, when reflection takes place at rigid boundary, the reflected wave will suffer 180 degree phase change. Okay, but in the second case, that's why for rigid boundary, the equation will become minus a sine omega t plus kx. But when it is free boundary means what? There is a boundary, but it is not at a definite distance. So what will happen when the progressive wave will move? It will suffer reflection, but the reflected wave will not suffer any phase change. That's why the equation of the reflected wave is given by A sin omega t plus kx. And when it is rigid boundary, what you have to do? Another negative sign here, just to indicate that reflected wave undergoes a 180-degree phase change when suffered reflection at rigid boundary. Okay. Now, consider these two courses together. Alright. Now, what is happening? So, you see what is happening actually when progressive wave propagating through a medium. Alright. It is propagating through a medium. Then, suffering reflection and the reflected wave passing through the same medium. You see, this is the incident wave and this is the reflected wave, and they are superposing on each other. So when they are superposing on each other, then a new type of wave is produced which cannot propagate through the medium, which remains stationary within the medium. That wave is known as stationary wave. Alright. So you see, when two identical progressive wave, okay, having same frequency but different amplitude, moving in the same direction, superpose on each other, then interference takes place. We learned. Okay, next, what is the case we studied? When two progressive wave, identical progressive wave, but different frequency, slightly different frequency, moving in the same direction, superpose on each other, then bits are produced. Okay, last chapter we studied. Now, in this case, what is happening? Two identical progressive wave, they are not moving. They are identical, means identical in every way. Amplitude same, frequency same, everything same. But they are moving in the opposite direction and superposing on each other. Then what will happen? A new kind of wave will produce which appears stationary in the medium. And this wave is known as stationary wave. So you see, when the formation of stationary wave takes place, the formation takes place like this. So you see, if you consider these points, just you look at this point, this point. You see, incident wave moving in this direction and the reflected wave just 180 degree out of phase. So what will happen? The particles at this point, they will permanently be at rest. That we never obtained in interference and bit. Interference and bit, what we have seen? That always the particles are vibrating. Okay, about their mean position, simple harmonic. But in this case of formation of stationary wave, what is happening? Look at the point, I have denoted it by N. What will happen? The particles will not vibrate at all. They will always remain stationary at this point. These points are known as nodes. These are known as nodes. Okay, nodes means what? The point at which particle always remain stationary. Particle always remain stationary. Okay. Now, look at these 2 points. Here, if you consider the particles at these positions. Now, the particle can vibrate with maximum amplitude. Look at it. At this position, the particle can vibrate with maximum amplitude. So, these points are known as antinodes and denoted by A. Antinodes. Means what? The point at which particles always vibrate with maximum amplitude. They are known as antinodes. Okay. Now, so I hope the concept of node and antinode clear to everyone. Next concept is coming. You see, when the stationary waves are produced, loops are produced like this, isn't it? Now, two successive loop together, if you consider these two successive loop together, they form one complete wave. Try to get the concept. What is one complete wave? For a stationary wave, two loops together produce one complete wave. Alright. So, you see, if this is one complete wave, means this distance is equal to wavelength lambda. Yes or not? So, if you consider the distance between two successive nodes, just look at it. Here one node, here one node, here one node. And the entire distance is lambda. So, you can say that the distance between two nodes is equal to lambda by 2. Is that clear? Now, similarly, the distance between two antinodes is also equal to lambda by 2. Isn't it? Just you consider, if we consider this half and this half, it is only one loop. Because this half, if I cut it and set it here, I will get one complete loop. Yes or not? So means what? The distance between two antinodes, it is lambda by 2. Clear? Now, come to the next concept, that if you consider the positions of node and antinode, in between two nodes there is an antinode. So, what is the distance between antinode and node? It will be lambda by 4. Okay. So, this is the first concept of node. What are nodes? Where the particle always remains stationary. Then coming the concept of antinode. What are the antinodes? The points where the particles always vibrate with maximum amplitude. That is antinode. Then the concept of one complete wave is coming. How you can get one complete stationary wave? Two successive loop together, they produce one complete stationary wave. So, according to that concept and according to the concept of positions of node and antinode, we have got this one, that distance between two successive node is lambda by 2. This is very important concept. You are supposed to learn and remember it lifelong. The distance between two successive nodes is lambda by 2. Distance between two successive antinode is also lambda by 2. And the distance between successive antinode and node is lambda by 4. Is that clear? Then, next concept is, if you consider one loop, within a loop, all the particles vibrate in same phase. All the particles vibrate in same phase. Alright, what does it mean? Just suppose I'm just drawing it separately. Suppose I have considered the first loop. So, if I consider the particles, all the particles, they will vibrate in same phase. Means all of them, they will, if they are vibrating, they will vibrate up. Is that clear? Means they are vibrating in same phase. Clear? Next one. Two successive loop if you consider, then the particles vibrate in opposite phase. Means here if in this loop the particles are vibrating in up, what will happen to the next loop? All the particle will vibrate just opposite, mean 180 degree out of phase, means they will vibrate in the downward direction. Okay. So this is the, if you consider in two successive loops, particles vibrate 180 degree out of phase. Vibrate 180 degree out of phase. 180 degree out of phase means what? Physically, they will vibrate simply in opposite direction. Okay. So, these are all basic concept of the formation of stationary wave. Then we have to know what are the characteristics of stationary wave. So, I have just noted down because already I have discussed the characteristics of the stationary waves. First point is, it does not advance in the medium. It remains stationary within the medium. Then second point, there are points which are called as node, and at the node all the particles, they remain stationary. Then third point, there are antinodes, means the points at which particles always vibrate with maximum amplitude. Then you know the distance between two successive node or antinode is lambda by 2, and distance between one antinode and one node is lambda by 4. Then next one is within a loop, means between loop, how it is formed? Between two successive node. All the particles, they vibrate in same phase. All the particles vibrate in same phase. But if you consider two successive node, then what will happen? Or if you consider two particles, suppose here is a node and you are considering one particle this side, another particle this side. Then these two particles, they will vibrate in opposite phase. Means what? Within two successive loop, particles vibrate in opposite phase. This another important point, that all the points of the medium, they passes through their mean position simultaneously twice for each period. When one stationary wave is produced, then two times all the particles, they will pass through their mean position at the same time. So these are the characteristics of the stationary wave. The next is coming, what are the differences between progressive wave and stationary wave? So I have just summarized the 4 important points of difference between the progressive and stationary wave. In progressive wave, from the name you can make out, it can advance through the medium with certain definite velocity. And stationary wave, they do not advance through the medium, they remain stationary within the medium. Then in case of progressive wave, these waves transmit energy from one point to another in the medium. Very important point. But for stationary wave, they are unable to transmit because they do not move. So they do not transmit energy through the medium. Okay, second important point. Then third important point, you know, in case of progressive wave, all the particles, they vibrate with the same vibration. They vibrate and the amplitude of vibration is same for all of them. Okay, very important point. But what we have observed in stationary wave, their amplitude varies from 0 to maximum. There are points where the particles do not vibrate at all, nodes, and there are points where particles always vibrate with maximum altitude, antinode. Okay, third point of difference. Then fourth point, we know at any instant the phase of vibration, here I have written means vibration. Phase of vibration varies continuously. Phase of vibration varies continuously from one particle to another. But in case of stationary wave, what we have seen, within one loop, all the particles, they vibrate in same phase. But if you consider two successive loops, then in two successive loops, always the particle vibrate in opposite phase. Then fifth point I have not written, I am just saying it because these 4 points, if you learn and remember and retain for your exam, it is enough. And fifth point is, there is another point, there are 2-3 more points, I am just discussing the important one. Then we have seen that in case of stationary waves, all the particles, they pass through the mean position simultaneously twice in each period. But this thing never happens in case of progressive wave. At no instant all the particles passes through their mean position at the same time. So these are the differences between progressive wave and stationary wave. That's all for today. Thank you, children.